This is problem 14-28. It is on page 756. After a long walk in the 12 degrees Celsius outdoors, a person wearing glasses enters a room at 25 degrees Celsius and 55% relative humidity. Determine whether the glasses will become fogged. Well, let's write down what's given and then talk about it. So let's see, the glasses have a temperature of 12 degrees Celsius. And let's see, let's do it this way. Let's put temperatures of glass. The temperature of the room, or the air in the room, is 25 degrees Celsius, but that air has 55% relative humidity. So we could write it this way. Either way is fine, as a decimal or as a percent. The question is, will the glasses fog? You've probably experienced this where you have a Coke can sitting out. Okay, so you bring a cold drink can, whether it's glass or aluminum or whatever, you set it out in the air and you notice condensation forming. Well, that's the same thing that happens when glasses fog. So the question is, will the glasses fog, and how do we decide? Well, here's how we would determine it. If the partial pressure of the water vapor in the air, right here, if the partial pressure is above the saturation pressure for a temperature of 12 degrees, well then yes, the glasses will fog, because the partial pressure of the water vapor can't be above the saturation pressure at that temperature, at the temperature of 12 degrees. Otherwise, some of the water has to come out. It's not at equilibrium then, and some of the water has to come out of the air. So basically, if the temperature, if this is less than, the question mark here, if this is less than the so-called dew point temperature, which is the saturation temperature at 12 degrees, at the partial pressure, at the partial pressure of the water vapor, whatever that is, okay, from here, then yes, they will fall. So if this is true, then yes, the glasses will fall. Well, we have to ask the question, what is the partial pressure of the water vapor? So just forget the glasses for a minute, take the air, what's the partial pressure? In other words, how much water is in the air? Well, it's the relative humidity, let me write it down. It's the relative humidity multiplied by the saturation pressure. Now you have to be careful here. There's two different saturation pressures floating around in this problem. One of them is just with the air, so forget that there are even glasses right now, okay? Forget that they exist. What's the saturation pressure of the water? Well, it depends on the temperature, right? 25 degrees Celsius. So if we look up the saturation pressure at 25 degrees Celsius and multiply it by the relative humidity, and by the way, the saturation pressure, here, let's do this, let's make this very clear. At a temperature of 25 degrees Celsius is, let's see, 55% for the relative humidity. Go look this up. The partial, or the saturation pressure at 25 degrees Celsius is 3.1698 kilopascal. So you plug that into your calculator and you find that the partial pressure of the water vapor is about 1.7434 kilopascals. What does this number mean? This number means that of all the pressure, which we don't know the total pressure, it doesn't really matter in this case, of all the pressure of the air in the room, the water is generating that much of it. 1.7434 kilopascals is being generated by the water vapor. Right? So now the question is, what is the saturation temperature at this level? Okay. So what would it take? What temperature would we have to have for this to be a saturation pressure? Does that make sense? So let's find out. Now, it's not so easy to go and look this up. You should turn to the steam tables in the back of your book. And since we're in the metric units, that's the first appendix. And look at the saturation tables. Now, if we look for a pressure of 1.7434, let's go to the pressure table. 1.7434. Well, guess what? They don't have that one listed. They didn't know we were going to try and solve this problem. They've got 1.5 and 2. Those are the two saturation pressures they have. Now notice the temperatures here. The temperatures are 13.02 and 17.5. Okay? Now we can already say, since the partial pressure is between 1.5 and 2, then the saturation temperature is between 13 and 17 degrees Celsius. Since 12 degrees is less than that, yes, the glasses are going to fall. But let's figure out exactly what temperature. Let's say that we took the temperature of the air in the room and we started taking the air temperature down. Well, the water vapor temperature would go down, the relative humidity would go up. When would the relative humidity go to 100%? That's what we're really asking here. Well, when this is the saturation pressure, that's when the relative humidity would be at 100%. Okay? So what we're trying to do is find the temperature where that would happen. So all we're going to do is interpolate. I'll show you my interpolation, because at first this is difficult for students to understand. So here's my interpolation. All I'm doing is interpolating between the 2 points I mentioned at 1.5 and 2 kilopascals. And if you're not sure where I got these numbers from, you should be able to see them in your text. And so when I performed this interpolation, I got 15.3 degrees Celsius, which, yes, is greater than 12 degrees Celsius. Okay, so since the temperature of the glasses is below this point, then the water vapor in the air around the glasses becomes supersaturated, right? It's above the saturation point. And so some of it has to condense out. And so the answer is yes. They will fall. Okay. How do you keep the glasses from fogging? Well, warm them up. What temperature do you have to warm them up beyond? 15.3 degrees Celsius. Okay. That's the temperature the glasses have to go to before they will not fog.